last class we discussed about enzymes. In that enzymes, the characteristic features of the enzymes we have discussed. Coming to this class, we'll discuss about how the enzymatic reactions are take place and what are the types of enzymes are there and what are the components are present within the enzyme. So all these are we'll discuss. Coming to the topic, there is an enzyme is there and substrate is there. In the last class also we discussed enzyme, substrate, and both these are combined forms that enzyme substrate complex. This state is called as transition state. This state is called as transition state. So transition state is the intermediate state. Transition state is the intermediate state. See, especially enzyme substrate. This is the free enzyme. This is the free substrate. Between these two, there is an interaction will be takes place. That is nothing but I already said there is an active site. Structures are present. See, within enzyme there is an pocket-like structures are present. These pocket-like structures, especially attach with the or interact with the substrate. So substrate molecules are very specific. Specific substrate molecules are interact with the enzyme active site. So there is an enzyme and substrate. See, this is enzyme substrate complex. This state is called as transition state. The transition state formation always bidirectional, not unidirectional. Always bidirectional, most of the cases. See here, why this one is bidirectional? I already said any enzymatic reaction requires favorable conditions. If conditions are not suitable, for suppose the best example, if the pH is not maintained, if the temperature is not maintained, metal ion concentration is not available. So if some conditions are required for enzymatic reactions, if the conditions are not maintained here, there is a backward reaction will be takes place. So that's the reason why here enzyme substrate complex formation is the bidirectional reaction. If conditions are suitable, there is a forward reaction will be takes place. If conditions are not suitable or not maintained, there is a backward reaction will be takes place. So enzyme substrate complex is stable, forward reaction will be takes place. Here enzyme substrate complex not stable. When this is stable, when conditions are suitable, when conditions are maintained, then forward reaction will be takes place. So this is the transition state. There is an enzyme and product formation. So this is most of the cases, this reaction is the unidirectional reaction, most of the cases, right? So that is about that enzyme substrate and enzyme product formation. So this is one of the graphical representation process. Generally we know there is an x-axis is there and there is an y-axis is there. We are already constructed so many number of graphs. So on the x-axis we are taking process of the reaction. Here process of the reaction is nothing but here this is the point, there is an enzyme and substrate. Okay, free enzyme and free substrate is there. This point is called as transition state. This point is called as transition state. This is the intermediate state. After that intermediate state, there is a product formation will be takes place. See, finally, this is the final step. This is the final step. So what I am telling here the process of reaction, free enzyme, free substrate. At the middle point, there is an enzyme substrate complex formation. The state is called as transition state, right? After the formation of transition complex or enzyme and the substrate complex, then forward reaction will be takes place. Finally, product formation will be takes place. So that is about related to that x-axis. Coming to the y-axis, we are taking here y-axis we are taking potential energy. Potential energy here indicates any reaction we are discussed. Okay, if one substrate is converted into product, certain enzyme, certain molecules are converted into products. There is nothing but substrate is converted into product. So during this conversion process, certain amount of energy is utilized. So in this process, what I am telling, so this is one of the enzyme and substrate complex. This is one of the enzyme and the substrate complex. Here enzyme substrate complex. Here product formation. Enzyme and the product formation will be takes place. So for the production of product, certain amount of energy is utilized. So that energy, okay, we are showing on y-axis. That energy we are showing on y-axis. So this is about the reactions. So here two examples we are taken. One of the blue line, here blue line indicates reactions without engine. Reaction without engine. So there is a product formation which takes place, but that product formed without engine or without involvement of the engine. And other one is red line. The red line indicates here product formation, presence of engine. So some engines are involved for the formation of product. See here the red line indicates presence of engine. The reaction, presence of engine. The blue line indicates here absence of engine. Absence of engine. So see, first of all we discussed about the blue line. See, there is a reaction which takes place. Engine, here no engine. For the blue line, no engine. Substrate is there, product is formed. For the blue line, substrate is there, product is formed without any involvement of engine. So in that process, very high amount of energy is utilized. For the conversion of substrate to product, certain amount of energy is utilized. See, that conversion without any engine, that conversion requires more energy. In the last class also we discussed carbonic anhydrase. There is in 200 molecules without any engine. Carbon dioxide is there and water molecules are there. There is an H2CO3 formation. See, without any engine, here for 1 hour 200 molecules are produced. For 1 hour. The same reaction, presence of enzyme, here 6 lakh molecules are produced for 1 second. 6 lakh molecules are produced for 1 second. So what I am telling here we are only constant. Last time we are only constant time. Not only time. Here energy also. See, absence of enzyme requires more energy. Presence of enzyme requires less energy. See this point. See the enzyme without any involvement of enzyme. Okay. Without any involvement of enzyme, more energy consumption takes place. See, this is the energy level. So, presence of enzyme, less amount of energy is utilized. So, here finally this graph is indicated. Here, activation energy required without enzyme more, and activation energy required with enzyme is less. So, that is the main theme of this graph. So remember, students, all of you, there is an enzyme substrate. See, this is the free enzyme, free substrate. That is the first step. Okay, here on the y-axis we are indicated potential energy. See, one of the transition state, that is nothing but enzyme and the substrate complex formation. Remember, here enzyme substrate complex formation means, remember, see, for the blue line, here also transition state is there, but there is no involvement of enzyme. So this is the transition state. Here there is an involvement of enzyme. So this is the center state. This is the reaction center point. So what I am telling, the blue line without enzyme, red line with enzyme. So without enzyme, more activation energy required for the conversion. Activation energy is nothing but the reaction. For the completion of reaction, certain amount of energy is absorbed or certain amount of energy utilized. So that is about that overview for the graphical representation. This graph representation, right? So what we discussed about the graphical representation, that one indicates, see, in human daily life we are using so many machines. Why we are using that machines? To reduce the human effort. See, any machine, what we are using, what are the fan or what are the different types of machines. There is in grinders are there at home, right? We are using different machines. The theme of the machine is reduce the human effort. In the same manner, see the enzymatic reactions. Quickly, presence of enzyme, the reactions are occurs very quickly, accurately, and reduces the energy levels. Whatever the consumption energy is there, okay, that is also called activation energy. Reduces that activation energy levels. So presence of enzymes, the reactions are quickly occurs within less time, and by the absorption of minimum energy, the reactions are completed. Presence of enzyme. Absence of enzyme, maximum time is taken and more amount of activation energy utilized. So what I am telling here, the reactions without enzyme is very long process. So the reactions, presence of enzyme within short span and accurately by the utilization of minimum energy, the reactions are completed. So what I said example here, missions in human life. Here missions are nothing but like enzymes. So missions with human life, there is a less effort, means the human energy, very minimum amount of human energy consumption takes place. Then human being without mission, more amount of energy utilized. So these are the best examples in our daily life. And coming to that, enzymes. Here, what are the components are present in the enzymes? See what we discussed. What is enzyme? Enzymes are nothing but proteins. See here also I said enzymes are nothing but proteins. No doubt about it. But along with the protein part, some enzymes contains non-protein part also. There is a protein part is there and non-protein part is there. But all enzymes are not having protein and non-protein part. See, some enzymes are having protein part and non-protein part. So here enzymes are classified based on the chemical composition. See, the very first type of enzymes are called as simple enzymes. Simple enzymes indicates here most of the enzymes are the simple enzymes. See, simple enzymes indicate the enzymes are only having amino acids. The enzymes which are made up of with only the amino acids. That is nothing but the enzymes are only made up of with the proteins. Part. Some enzymes only contains protein part. So that kind of enzymes are called as simple enzymes. And coming to the next one, conjugated enzymes are there. Conjugated. Here conjugated means there is a combination is there. What are the components? What are the combinations are present here? The very first case, here conjugated enzymes, there is a protein part is there, non-protein part is there. Here there is a protein part is there and non-protein part is there. We know protein part is made up of with the proteins, that is nothing but amino acids. Here protein part is made up of with the protein or amino acids, right? And the conjugated enzymes, the second part is non-protein part. See, these are also called cofactors. Non-protein part of any enzyme is called as cofactors. What is cofactor? Cofactor is nothing but any enzyme contains other than protein part is called as cofactor. Any enzyme contain other than protein part is called as cofactor. Simply, non-protein part of an enzyme is called as cofactor. So here cofactors are there. See, the combination of protein part and non-protein part or combination of protein part and cofactor. See, that kind of enzymes are called as holoenzymes. Holoenzymes always made up of with two types of components. One of the component is the protein part, other component is the non-protein part. These non-protein parts are called as cofactors. Again, cofactors are classified into three groups. Remember always cofactors are here either organic molecules or inorganic molecules. Always the cofactors for any enzyme here either organic components or inorganic components. But here based on the association between enzyme and the cofactor, again these are classified into three groups. See, whatever that non-protein parts are present within the enzyme, these are called as cofactors. That cofactors are majorly two types of components, either organic components or inorganic components. See, the interaction between enzyme and the cofactor, enzyme and the cofactor. These can be grouped into three types. These can be grouped into three types. So the very first one is the coenzyme. Within cofactors, three groups are there. Coenzyme is there. Metal activators are there. Prosthetic group is there. These three groups are either organic molecules or inorganic molecules. See the very first one, coenzyme. What is coenzyme? Coenzymes are loosely attached organic part of enzyme. See, there is an enzyme is there. This is the enzyme. There is a loosely attached organic component is there. For suppose, this is the enzyme. This is the enzyme. And this is the organic molecule. Between these two, there is an attachment is there. That attachment is not permanent attachment, loose. There is a loosely attachment is present between organic molecules and the enzyme. So that kind of components are, that kind of cofactors are called as coenzymes. Coenzymes are loosely attached organic part of enzyme. Right? Examples are here. Vitamins are the best examples, and ADP is the best example. Some reactions, there is an ADP molecule, presence of phosphate is converted into ADP. Right? So there is an ADP and NAD, right? And some cases NADP. So all these are the organic components, but these are loosely attached with the protein part. These are loosely attached with the protein part, or these are loosely attached with the enzyme. That's the reason why these are called as coenzymes. Coming to the next one, metal activators. See, metal activators means these are definitely inorganic, loosely attached inorganic part of enzyme. Loosely attached inorganic part of the enzyme. Loosely attached organic coenzyme. Loosely attached inorganic metal activators. Loosely attached inorganic molecules. These are metal activators. We know best examples. There is in salivary amylase enzyme requires chlorides, and there is in DNA polymerase enzyme requires magnesium ions. So different types of enzymes are there. Okay, see, some enzymes for their activity, for the enzyme activity, some metal ions are required. See, loosely attached inorganic part of an enzyme, these are called as metal activators. See, best example here, iron, magnesium, zinc. Iron, magnesium, zinc. So that is about the metal activators. That is the difference between coenzyme and metal activators. Coming to that last topic is that prosthetic group. Within that prosthetic group, no doubt these are also organic molecules, but the attachment is different. In the first case also organic molecules, in the last case also organic molecules. These are loosely binded with that protein part, and these are tightly binded with the protein part. These are tightly binded with the protein part. So the interaction is different. These are loosely bind to the protein part, and these are tightly binded with the protein part. So the tightly attached organic part, it cannot easily separated from the protein part of the enzyme. It cannot be easily separated from the protein part of the enzyme. So these are tightly attached. The interaction is the permanent interaction. This is the temporary interaction. This is the permanent interaction. Right? So tightly attached organic part, it cannot easily separate it. So the best example here, peroxidase enzyme is there and catalase enzyme is there. See, both these enzymes are attached with the heme part, that is nothing but iron part. So permanent interaction is there between protein part of peroxidase enzyme and the heme molecule, and permanent interaction is there, catalase protein part and the heme part. So there is a permanent interaction is present between organic molecules and the protein part of the enzyme. These are called as prosthetic groups. So that is about the composition of the enzymes. We discussed simple enzymes and the conjugated enzymes. So here conjugated enzymes, see, protein part is there, non-protein part is there. Non-protein parts are called as cofactors. Right? Again, cofactors are grouped into three types. Here first one, coenzyme. See, organic molecule, loose interaction. Metal activators, inorganic molecules, loose interaction. And prosthetic groups, here organic molecules, permanent interaction or tightly attached with the protein part. Right? So that is about the components which are present in the enzymes.